Hi everyone. The purpose of this tutorial is to familiarize you with the balanced equations simulation on the PhET website. So here we are on the CANLEAD site, and if I click on direct link to simulation, it'll take me to a page that looks just like this. And as usual, there are some sample learning goals and some teaching ideas that you might want to look through from other teachers that have worked for them. And of course, there are also related simulations, and in this case, reactants, products, and leftovers is a related one. So what you want to do on simulation is click Run Now, and it'll open up to a page that looks just like this. And this is in fact a simulation. It's a very simple simulation, so I'm not going to take too long to explain it. Now, you have three main options. Well, actually, let me start off by saying there are two tabs here. There's Introduction, and then there's the Balancing Game. And the Balancing Game is just a game. It's not an actual simulation. So in the actual simulation, you have three options. You can either make ammonia, separate water, or combust methane. And based on what I choose, I'll have different reactants and products, obviously. So let's just do make ammonia because that seems to be a very simple one. Now, balancing equations has proven to be very difficult for students, especially when you have diatomic molecules involved. And so what really helps is a nice visualization of what's going on. So let's say that I want to make at least one NH3, and that's symbolized here by the three white hydrogens and the one nitrogen in blue. Now, what do I need to do that? Well, if I have one H2 or I have one N2, I know I'm going to have one of each because NH3 has nitrogen and hydrogen in it. So how does those combine to make this? It doesn't make any sense, at least for a lot of students. What does help though is that this simulation has balance scales and bar charts. So I have a balance scale here, or I can have a bar chart. So on the balance scale, it tells me that my nitrogen and hydrogen are not balanced, where in fact the left hand side has two nitrogens, which is more than what the right hand side has, and vice versa for the hydrogens, where the right hand side or the products have three hydrogen atoms and the reactants only have two hydrogen atoms. And so how do I fix this? Well, I can add more hydrogen here, but that doesn't work because my hydrogens then become too much on the reactant side, so I have to add one here. And that still doesn't work because now we're teeter-tottering, but my nitrogens have balanced out because now I have two nitrogens on each side. And in order to make this work, I have to go up to 3, and everything is happy. So in this case, I use a very analytical approach where you may want to use a more holistic approach. So let's say that we're trying to separate water. Instead of using these scales to balance out, I can just kind of say, okay, well, I have an O2 here. I know I'm going to have O2, so because I have an oxygen here. So I know that if I have one H2, my hydrogens will balance if I have one H2 on the right hand side, and I have one oxygen there, so I have to have at least one there. So now that doesn't balance, which means I have to go back and do that. And now my oxygens are balanced, but my hydrogens aren't, and I can do that by balancing that. So you can see that there are three different visuals going on here. You have your actual equation with your coefficients. You have your two black boxes that show products and reactants together, and then you have your balance scales, or you can choose to do a bar chart, either way, that show individual elements or atoms. And so that's very simple, and I hope that you get the chance to use this in your class.